Alright, so for Lab 9 we are going to be doing a little bit of oxidation reduction because that is essentially what our Lab 9 is about. So you need to understand some of these basic rules. Probably the most important ones I would say are that hydrogen almost always has an oxidation state of +1, while oxygen almost always has an oxidation state of -1. As well as that the oxidation state of elements is 0, and that should pretty much cover it. Okay, so we've got this equation, and we need to essentially be able to balance it as an oxidation reduction. So I've written it down right here, and let's go ahead and first assign what our oxidation is for each element. So we've got hydrogen here in the water, so that's going to be +1 for a total of +2 because there's two of them. Now oxygen has -2, and so it's going to, but there's only one, so it's going to be -2. So the net charge of this molecule is going to be 0, which makes sense because there is no net charge on this molecule. If there were, it would look kind of like that, or something like that. Or without the brackets, kind of like on BrO3 like we have over there. Okay, so we figured out that this is they're just standard oxidations for the water. I'll redraw the water in. And so the bromine will have an oxidation state of 0. That is because they're connected, so you typically can assume that these types of situations they have an oxidation state of 0. Now let's go over to the other side. So clearly here bromine has an oxidation state of -1 because it's the only one. So there's only one of them, so the total oxidation is -1, which makes sense because it adds up to that -1. Now for the oxygen, each one is usually -2, and there's 3 of them, so it has a -6, and the bromine must then, since it adds up to -1 because of this guy, that tells us that our bromine has to be +5, because that's the only way that we can get our molecule to have a net charge of -1. So now that we've found these, we can figure out what is oxidizing and what is reducing. So remember, I think I've seen the abbreviation oil rig used. So that means O oxidizes. That's oxidizes. If lowered, yeah, and then reduces if gained electrons. If you gained electrons. Oxidation is for lost. If you lost electrons. So that's oil rig. So oxidation occurs if you lose electrons, and reduction occurs if you gain electrons. So remember, electrons have a negative charge, so this guy right here has gained electrons, which means he has been reduced. And this other guy, let's see, where has someone? Okay, so the other bromine went on to become a 5+, so he has lost electrons. So that tells us that one of them has been oxidized, one of them has been reduced. Okay, so we're going to start off by writing out our half reactions. So whatever's reduced, whatever's oxidized. So in this case, we've got the bromine becoming bromine 1-. So we're doing the guy that got reduced. And just because we have a Br2, I'm going to make this other Br just be 2 of them, and so that is our reduction. For our oxidation, Oh, and here I forgot to put lost means oxidized. So for our oxidation, we are essentially going to have Br2 becoming 2Br03, and again, the only reason I've used 2 is because we have Br2 to start off with. And so what else is occurring on here? What in terms of electrons and hydrogens? So we needed some oxygens, so that means that we're going to need some waters over here. How many we're going to need? Well, we have 3 oxygens on the right hand side, so we're going to need 3 waters on the left hand side. Oh, that's out of the screen. Let me readjust that. So we're going to need 3 waters, and that then balances the oxygens. But now we have to balance the hydrogens. So you typically start off by balancing the largest molecules, and then by balancing the oxygens, and last by balancing the hydrogens. Well, not last, because then you balance the electrons, but let's first go ahead and balance the hydrogens. So over here we have 3 sets of 2 electrons, which means a total of 6 electrons. Oh, I'm sorry. Looks like I forgot to do that. I forgot that we were doing 2 oxygens. So actually, this 3 then, because on the right-hand side we actually have 6 oxygens, because it's 2 times 3. So we're going to need 6 waters for those 6 oxygens. So that will also then give us 12 hydrogens. So we will have plus 12H plus on the right-hand side. And finally, what you want to do is go ahead and balance the electrons. So I'm going to do that on both of these equations. So on the top one, we essentially gained 2 electrons because now we have 2 minus total, whereas before we had a 0. So I need 2 electrons on this side in order for there to be no net change of electrons. Okay, so we have 2 electrons now on the left-hand side, and they're absorbed by the Br, and therefore become -1 for each one of the Brs. Now, let's balance the bottom. So you kind of have to add up the net charge in order to figure out what you have left. So because we have here, and I forgot to draw that, so that might help, a -1 charge. Remember, we had that -1 charge at the very beginning, all the way up here. Our net charge on the left-hand side from the Br03, because there's 2 of them, is going to be 2 minus, and on the left-hand side there's nothing that's charged, so it's a net charge of 0. But on the right-hand side, we not only have a -2 from the 2 Br03, we also have 12 hydrogens. So that gives us a net charge of 10 plus. So in order to avoid that 10 plus charge, we're going to need to add 10 electrons to this side. Now, what we finally need to make happen is for all of the electrons to balance out. So we need to multiply this equation that we had so that there are the same number of electrons on the left-hand side total as on the right-hand side. So in order to get this 10 electrons, we are going to have to multiply both sides by 5. And that will give us 10 electrons plus 5 Br2s plus, going to, now 5 times 2Br minus 1 is going to be 10Br, and each one has a -1 charge. Okay, so this is essentially what we have been trying to work towards to get right here. So we can then go ahead and just add these up and cancel out any electrons. So for example, both sides have 10 electrons, so those can disappear, and that gives us our net balanced reaction, which you can then go ahead go ahead and write down as your final balanced equation. Now, if you have hydroxide or a problem that's in basic solution, the only difference is that after you balance the hydrogens, you then go ahead and rebalance it with hydroxides. So for example, in that last problem, how we ended up with, I'll just write out the net equation, so that we were supposed to end up with 6Br2 plus 6 waters going to 2Br03 minus 1 and plus 10Br minus, also minus 1, plus 12 hydrogens. So the same thing occurs here, except now instead of balancing the hydrogens with electrons, or I guess you can do it afterwards, you then go ahead and add that same number of hydroxides. So we add 12 hydroxides to this side and 12 hydroxides to this side. Now what that's going to do is it's going to convert all of these hydrogens plus hydroxides into waters. And over here we have 6 waters. So you can go ahead and cancel those waters out with each other. So for example, this would turn into 0 waters and this would turn into 6 waters. And so our final reaction would look like 12 hydroxide molecules plus 6Br2. Now the 6 waters we've canceled out, going to 2Br03 minus 1 plus 10Br minus 1 plus 6H2O. So notice that because it's a basic solution, we only have hydroxides left. There are no hydrogen ions left, because in a basic solution that would not occur. So that is essentially how you would do the basic if it was in a base versus an acid. Alright, hope that helps, and let's go on to Lab 10.